Hello, in this video I want to go over an old Edexcel S3 question which involves combining random variables, in particular normal distributions, because it is something that does cause some confusion at times when we're looking at the combination of them, whether we're actually sampling, taking 15 independent observations, or we're just simply taking one and timesing it by 15, and it's important we get the distinction right. So if we let X be the distribution of paperbacks, they're normally distributed with mean 2.1 and variance 0.39. That's the paperbacks. And then the distribution of Y is normally distributed, and this is the hardbacks, which are 4.0, thickness 4.0, and variance 1.56. That's the hardbacks. Okay, so we're considering 15 of these books. Now this is the thing, we are talking about 15 independent observations of this distribution. So we could let L be sum of 15 independent observations of X. So we'll call them X1, X2, X3 up to X15. So the length of these is X1 plus X2 plus X3 plus ... up to X15. Okay, we need to find the mean and variance of these. Well, clearly the mean is just going to be the mean of each one of these individually up to the 15th, which is basically 15 times 2.1, which is equal to 31.5. Now here's the thing with the variance. Variance of L is same thing, variance of X1 plus the variance of X2 plus up to the variance of X15, which is 15 times 0.39. And that equals to 5.85. Now, the thing is, not to confuse, this is where you don't want to be falling into a trap of saying L is 15 times X. That would be one single observation of X times them by 15. And there might be some circumstances where that happens. For example, if for some reason the price of these books was proportional to, based on the thickness of them, times by 50. So the price of the book was 15 times by whatever the thickness of the book was. L could represent price. So it's basically a function of a random variable, rather than taking 15 independent observations of that random variable, which is quite different. So if ever you're taking different samples, different observations from a distribution, we're always doing like this. But if you've got somehow a function of a random variable, let's say, which could have certain meaning in context, then we would be doing, if we had, just to go back to that, X is equal to L is equal to 15X, then the var of L would be equal to 15 squared times by the var of X. But that's not what we've got here. It's not a function of it. It is 15 independent observations of it. So it's times by 15 rather than times by 15 squared. Okay, so now we can say, therefore, that L will be normally distributed with mean 31.5 and standard deviation 5.85. So now it's pretty straightforward. We want the probability that 15 books will fit on the shelf, and the shelf is 30 centimeters long. So we need the length of these 15 books to be less than 30. So we want the probability that X is less than or equal to 30. It's arbitrary whether I use a strict or inclusive inequality because it's a continuous one, but I've put it as a inclusive inequality. It doesn't really make any difference. Right, so at this point I'm not going to use the Z. I know some people will do this and then use the tables, but we're going to use the calculator here. So we want to press menu, and on this branded calculator that many people use, it's menu 7. And it's normal CD, and the lower tail, well, we want the lower tail to be unlikely small. We can put 0 in here because that will give us pretty close to a number because that's a long way off the mean, but you can put something even smaller if you want to be safe, minus 1,000, minus 10,000 or whatever. It needs to be a very unlikely small to not affect the answer. So then the upper is 30, and the standard deviation, and you can put the square root into the calculator. Remember, the standard deviation is the square root of the variance, so that's 5.85, and the mean of the distribution is 31.5, so we get the answer 0.2676. Okay, just so that's the answer to that. Okay, so that's the first part. Okay, the second part is very similar really. It's just starts talking about 5 hardbacks and 5 paperbacks. So I'm just going to let G be equal to x1 plus x2 plus x3 plus x4 plus x5 plus 5 different observations of y for the hardbacks, and we can then say the expectation of G is equal to ex1 plus ex2 so on to ex5 plus ey1 plus ey2 up to ey5. And remember, these are all same. These all have the same mean and variant mean as the original distribution. So that's 5 times 2.1 plus 5 times 4.0, and that also equals to 30.5. Well, not also, it equals to 30.5. So the mean is now 30.5. Okay. And the variance, similarly, of G is equal to variance of x1 up to the variance of x5 plus the variance of y1 up to the variance of y5, basically 5 times each one. So that's 5 times variance x1 plus 5 times variance of y1, sorry, x and y, so that's 5 times by 0.39 plus 5 times by 1.56, and that equals to 9.75. So we've got G is normally distributed with mean 30.5 and variance 9.75. So we want the probability that these 10 books add up to less than 30. Okay, so let's bring the calculator back up. The menu, we're going to put menu 7 up again. It's the normal cumulative that we want. Okay, the lower tail I'm going to put 0 in again. As I say, some students go over the top here, but it doesn't matter. 0 is, I mean, it's nearly 10 times the standard deviation away. So that's going to be easily good enough. But yeah, if you want to put minus 1,000,000 in, of course, you're going to get the same answer, or very well, the same answer really. So lower 0. The upper, we're going to put 30 in. The standard deviation, we put the square root of 9.75. And the mean is 30.5. So we have that number there, 0.436 to 3 significant figures. Okay, and finally there's one extra. Okay, so we're back to talking about 15 of these. So this is our L that we had from before, the x1, x2 up to x15, where L is normally distributed with mean 31.5 and variance 5.85. And what we want is the actual size of the thing, because it's talking about what the length of the shelf needs to be in order that it's pretty unlikely that it won't be long enough. So what's this number here? Let's call it little l, such that 99%, this number here is 0.99 here. What's the value of L for this distribution? So this is where we're working backwards. We have an area or a probability, and we want to find what the value of the actual value is for the that you're sampling from the distribution. So again, I'm not going to use the Z transform to the Z and use phi minus 1. That type of thing, for those of you who've been taught that way or have to use the tables. We're going to use a calculator because the calculator is perfectly acceptable for OCRA. So we just need to make sure we use the inverse normal function. So we can just say, and I think the diagram says it all really, don't have to write anything fancy. So L equals 2, the calculator up again, menu 7. Now we want inverse normal, so that's 3. We want an area of 0.99. We want a standard deviation of the square root of 5.85. And we want the mean of 31.5. And that gives us the answer 37.1 to 3 significant figures. 37.1 is 37.1. Okay, just feeling a little bit guilty for not writing any working of steps here. We want the probability L is less than L equals to 0.99, I suppose, on reflection. We ought to put that, but the diagram and the symbols there say the same thing. Okay, so L is 37.1. So that's it. Question is complete. I think the main thing is to make sure that you're combining the variances properly and you're not incorrectly applying this rule. Variance of ax plus b is equal to a squared variance of x. We know the b drops, but the a squared, we're not squaring because it's not a function of a random variable as such. It's a sample of a random variable. You're taking 15 observations of it, and then it's always times by the number rather than the square of the number. Okay, hope you found this useful. Goodbye.